Hello. In this video, we are going to look at some examples of how we can find the interval and radius of convergence for a given power series. The main process of finding the radius and interval of convergence is going to be to take our series and run the ratio test on it. Can also we can also sometimes use the root test, but the ratio test is the one that will work the nicest most often, so that is the one we are going to use. So running the ratio test, call the ratio test, tells us to look at the limit as n goes to infinity of the absolute value of add 1 to all the n's, so x to the n plus 1 over n plus 1 factorial, all divided by our regular sequence, x to the n over n factorial. Keep change flip. Over n plus 1 factorial times n factorial over x to the n. Some simplification. Remember that n plus 1 factorial is the same as n plus 1 times n factorial. So this equals 1 over n plus 1 up in the corner here, meaning this fraction is going to be 1 over n plus 1. And the fraction of x to the n plus 1 over x to the n, x is just a number, so the x to the n's cancel, leaving us with an x to the first in that numerator. I'll repeat the fact that n is going to infinity, but x is just a number. It could be 100, it could be e, it could be 5, but it's a number. And n is going to infinity. So if I had any number divided by something going to infinity, this is just a growth rate where this limit comes out to be 0. Meaning, we just ran the ratio test and we got the limit to be 0. So our limit equals 0, which is less than 1. So by the ratio test, this series doesn't care what x is. Like we said in this line, I could put any number in for x, this limit is still going to be 0. So meaning back here, I could put any number in for x, the limit will still be 0. And going all the way back here, I could put any number in for x, and the limit will still be 0 when we run the ratio test. So by the ratio test, because our limit, no matter what x I use, is 0, this series converges for all x, meaning the interval of convergence is negative infinity to infinity, all x values, and the radius of convergence, if I go from any center point, the center is 0 here, but would not matter what the center is, from the center out to infinity is a distance of infinity. So the radius of convergence is r equal to infinity. However, getting the limit to be this nice might not always happen. So let's take a look at another example. Suppose we are looking at the series n factorial 3x plus 2 to the n. So again, I'm running the ratio test. And I have the limit as n goes to infinity. We plug in n plus 1. So n plus 1 factorial times 3x plus 2 to the n over n factorial, n plus 1 in the top, n factorial 3x plus 2 to the n. This simplifies down into being the limit as n goes to infinity of n plus 1 over n factorial is just n plus 1. We had this same work up here, except we now have the reciprocal. So we get n plus 1. And then 3x plus 2 to the n plus 1 divided by 3x plus 2 to the n is 3x plus 2. Now, we want to consider some things of what if I plug in these different numbers. If I plug in x equals, say, 5. If x equals 5 goes in here, I'd have 15 plus 2, which is 17. And then I'd have this n plus 1 going off to infinity. Infinity times 17, still infinity. If I plug in x equals 0, I'd have 0 plus 2. And infinity times 2, still going to be infinity. So this limit is going to be infinity. However, there's going to be one value we need to talk about. Our limit at the end of this, again, we ran the ratio test. So L is equal to infinity, which is bigger than 1. So by the ratio test, the series n equals 1 to infinity, n factorial 3x plus 2 to the n diverges for all x. Does not matter what x I plug in, except it matters a little bit. What if I put x equals negative 2/3 in here? If x equaled negative 2/3, every term of this series would be 0. Doesn't matter what n is. At any term, I'd have 3 times negative 2/3 plus 2 to the n. And 3 times negative 2/3 is negative 2. And then plus 2. This is 0 to the n. So every term of this series becomes 0. And 0 plus 0 plus 0 plus 0 plus 0 is still 0, meaning the series does converge for one value and one value only. So it diverges for all x except when x equals negative 2/3. X equals negative 2/3 is actually the center of this series. It's what makes this term to the n 0. So x equals negative 2/3 is the center. And our series diverges for all x except at the center, making our interval of convergence just the point -2/3. That is it. And the radius of convergence, again, the radius is the distance from the center to the furthest boundary point of the interval. Well, the interval is the center, meaning the radius is 0. Yeah. So we've seen a case where the radius is infinity and our interval is all real numbers. We've had a case where the interval is just a single point and the radius is 0. Are those the only two options, or are there more? We are going to take a look at one more example. So find the interval of convergence and radius of convergence for the series n equals 1 to infinity of x plus 3 to the n divided by 4 to the n times n. Again, we want to run this ratio test. So we have the limit as n goes to infinity of x plus 3 to the n plus 1 over 4 to the n plus 1 times n plus 1, all over x plus 3 to the n over 4 to the n. Keep, change, flip. X plus 3 to the n plus 1 over 4 n plus 1 times n plus 1 times 4 to the n times n over x plus 3 to the n. Things that cancel. The x plus 3 to the n plus 1 divided by x plus 3 to the n is just x plus 3. The 4 to the n plus 1 and the 4 to the n is just a 4 in the denominator. And then we have n over n plus 1. When we're worried about this limit, the limit is only caring about the n stuff. So we're going to pull this x plus 3 over 4 outside our limit because that doesn't depend on n, and keep it inside absolute values. So limit n goes to infinity of n over n plus 1. The part that's just n, that's a rational limit that we know. This limit is, well, the limit portion is 1, because we have a rational with the same degree. So we ultimately just get x plus 3 all over 4. So this means by the ratio test, the series n equals 1 to infinity of x plus 3 to the n over 4 to the n times n converges when our limit is less than 1. So this converges when our limit is less than 1. Working out that inequality, multiplying everything by 4, we get x plus 3 is less than 4. And what the absolute value means is that our value of x plus 3 is bigger than -4, but smaller than 4. And now we can add or subtract 3 from both sides to get -7 is less than x is less than 1. So here is our full limit. This means here is our interval partially. There's a little bit more we need to do with this interval. However, this is our radius. The radius of convergence. And we'll see a little bit more why that's our radius in a little bit. It's r equals 4. But our interval of convergence is somehow between -7 and 1. The reasons we're not completely done is because if I took -7 or I took 1 and I plugged that in to this limit here, say I plugged x equals 1 in, then I would get the limit n goes to infinity of 4 over 4 times n over n plus 1, which that is 1. If you recall from the ratio test, the ratio test is inconclusive when r equals, or when the limit equals 1. So if I plugged x equals 1 in, I would get a limit of 1. The ratio test, the thing we're basing everything on, is inconclusive. And the same would happen with -7. If I plug -7 in, I would get -4 over 4. And that limit is still going to be 1. So for x equals -7 and x equals 1, ratio test is inconclusive. So we need to test those with a different method. I'm going to zoom in, and we are going to test if x equals 1, we would have the series n equals 1 to infinity of 1 plus 3 to the n over 4 to the n, which is the series n equals 1 to infinity of 4 to the n over 4 to the n times n. 4 to the n over 4 to the n means this is the series n equals 1 to infinity of 1 over n. This diverges because it is the harmonic. So it diverges at x equals 1. If x equals -7, I'm going to plug -7 into our series, and we'd have the series of n equals 1 to infinity of -7 plus 3 to the n all over 4 to the n times n, which is the series n equals 1 to infinity of -4 to the n over 4 to the n times n. And -4 to the n over 4 to the n, you can see this by rewriting this as negative 1 to the n times 4 to the n with exponent rules. The 4 to the n still cancel, but we now have this negative 1 to the n. So this is the series n equals 1 to infinity of negative 1 to the n over n. But we know the series negative 1 to the n over n converges by the alternating series test or because it is the alternating so our power series converges at x equals negative 7, but it diverges at x equals 1, making our interval, since it diverges at 1, we don't include 1 on our interval. Since it converges at x equals negative 7, we do include that on our interval. So our interval of convergence is negative 7 to 1. Instead, we would address the fact that r is 4 again, besides this inequality, which tells us it's 4. But why does that tell us it's 4? Well, our center here is x equals negative 3. And to go from negative 3 to positive 1, or from negative 3 to negative 7, whichever direction we go, that is a distance of 4. So, since we have a center of negative 3, because of the x plus 3, getting down to negative 7 or up to positive 1 is a distance of 4 from our center of negative 3. We will formalize in the next video all of these rules for what our interval of convergence or radius of convergence can be.